Okay, now it actually is day 16, and I'm going to try to do day 16. Now, um, during the day, I took a leak. A leak. I did take a leak, but anyway, I took a look at a couple of the private leaderboards that I'm on, um, and found that people were not finishing this problem. So I have not looked at this problem yet, but based on the private leaderboard I was looking at, uh, it might be kind of hard. So if I can't get through it, I can't get through it. But we'll see what it looks like. Also, I'm a little bit sniffly, so. Sensors have led you to the origin of the stress channel, yet another handheld device, just like the one that elves gave you. You don't have to see elves. For my elephants, they must have gotten lost. One figured out how to turn in the ground rumbles again, much stronger this time. You scan the cave with the handheld device, it reports mostly igneous rock pressure. This is a volcano. You need to get it's 30 minutes, don't have time to go out the way back in. You scan the cave for other options, discover a network of pipes and pressure relief valves. You aren't sure how such a system got into a volcano, you don't have time to plane. Device produces a report of each valve's flow rate if it were opened, the tunnels you could use to move between the valves. Um, there's even a valve in the room the elephants are standing in labeled AA. You estimate it'll take you 1 minute to open a single valve and 1 minute to follow any tunnel from one valve to another. What is the most pressure you could release? Uh, for example, suppose you had the following scan output. Um, all the valves being closed. You start at valve AA, but it must be damaged or jammed. It's floated to zero, so there's no point in opening it. However, you could spend 1 minute moving to valve BB and another minute opening it. Doing so would release pressure during the remaining 28 minutes at a flow rate of 13, a total eventual flow rate of 28 times 13 plus 364. You spend your third minute moving to valve CC and your fourth minute opening it, providing an additional 26 minutes of eventual pressure release at a flow rate of 2 or 52 total pressure released by valve CC. Making your way through tunnels like this, you probably open many or all the valves by time. You need to release as much pressure as possible to be methodical. Said, okay, minute 1, minute 2, move to open valve DD, minute 3, CC, you move to valve BB, you open valve BB, move to valve AA, move to valve 1, move to valve J. Okay. This approach lets you release the most pressure possible in 30 minutes with this valve layout, 1651. Work out the steps. Um, okay, yeah, this is the sort of thing where um, brute force is probably not going to do you much good. Anyway, let's write the parsing code um, where um, okay, so at least we can do that, and then I'll think harder about how I want to solve this. So let's say raw equals this. Okay, um, and let's import data classes. Not typing. From data classes, import data class. Okay, so add data class, class valve, um, which is name, string, flow, int, tunnels is a list of strings. Okay. Um, and what's this whole problem called? Um, it's called a network. Um, so data class, class network is going to have valves, which is a list valve. Okay, that's smart. I knew I would want to do that. Um, so let us do this. Yep. Okay. Can you write this for me? Name, flow, tunnels. Uh, no, so that doesn't work. Um, so let's say, well, again, we use regex, port RE. Let's say regex equals, oh, is it going to write the regex for me? Valve A to Z plus has flow rate equals 0 to 9 plus tunnel leads to valve. Gotta put a question mark here because it might say valve, might say valves. A to Z, comma, space, plus. Okay, so that seems right. Um, okay, that seems right too. That seems right too. Okay, good. Um, so let's try running this and see what happens. List index out of range. Okay, so that didn't work. Um, let's say lines equals raw dot split lines, and let's say re dot match regex line 0. And I can never remember how to use these things. Dot group, no, dot groups. Yeah, so let me do that. Let me try this. Re dot match dot groups. What is this? Seriously, we really need a null coalesce operator, which is result equals re dot match rgxs if res equals res dot groups else. Yep. Okay. So now let's try that again. Could not parse. Valve HH has. Okay, so let's say lines 7, regex, re.match, regex, lines 7. Why did that not match? Valve HH has flow rate equals this tunnel leads to valves A to Z. Okay, I'm doing something stupid here. What if I say what if tunnels? Okay, that's the issue. Tunnel or tunnels, lead or leads. Okay, that's dumb, but that's what you get for not reading carefully. Tunnels leads to valves. Okay, so let's try it again. Okay, and now what did I call that network? No, what did I call it? Network. Valves, this, the flow. Tunnels equals this. Okay, and so this is so I start there, and I have three. I always have three choices. I can, or not three choices. I can always open, go, 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 and so that puts me on a queue and says, um, I want to save as much as possible. And now, so that's okay. So one thing is that I'm never going to want to um, open something that has flow rate 0, right? So um, the second thing is I would rather open things that have higher flow rates. DD, DD, CC, BB, DD, BB. So if I open a valve today, and one thing I need to do is say open bool equals false. Um, if I open a valve today, then I know I'm going to get n minus 1. Okay, so um, part of me wants to have a priority queue where I pull off um, the biggest at this point, but um, no, I feel like I need to brute force this with the caveat that um, 1, 2, 3, 4, 5, 6. So there's only 6 factorial possible orders to open them in, right? Well, but there's more ways to travel, I guess. Um, well, let's start brute forcing it and see what happens. Okay, or at least let's like write out what uh, most pressure self uh, num steps int equals 30 start string equals AA and goes to int. Okay. Um, actually, I don't need to do this. What I need to do is val, let's say, um, uh, okay, I think that's how I did it. And here, let's say, name equals, yeah. Okay, so that seems fine. And I'm, I'm probably gonna want name tuples here. So let's say Q equals this. Class Q item, which is a named tuple, and it is going to have location, which is a string, time, which is a string, released, which is an int, and open, which is a set of strings, right? Q item, start 0, 0 set, okay? What do you mean Q item is not defined? Just defined it. Do I need to define it outside of this class? I can't do nested classes. That's irritating. Time is an int. All right. Well, let's just do, okay. While Q item equals Q dot pop left, okay. If item dot, actually, let me do it this way. I'll unpack it. Loc time released open equals Q dot pop left. I shouldn't call something open because that's the problem. Then I probably shouldn't need to do this, I think. Okay. And let's say valve equals self dot valves by name loc. Okay. If valve dot flow bigger than 0 and valve not in open, open equals open valve. Released plus equals valve dot flow times num steps minus time. I think -1, right? Because it takes one thing to open it. And q dot append q item loc time plus 1 released open. Actually, let me do this. Loc time plus 1 item equals q item loc time plus 1 released plus valve dot flow times num steps minus time minus 1, and then open or loc. Okay, and then q dot append item. Okay, and now for tunnel and valve dot tunnels, this is going to cause too much backtracking. To do eliminate backtracking. I'll try it without it first. For tunnel and valve dot tunnels. Item equals q item, q dot append item. Best equals minus 1. If time equals num steps, let's pressure 30 AA. So this is probably going to run too long, but we'll try it. Unhashable type valve, because okay. Okay, yeah, so that's not going to work because it's just doing too many things. So what I want to do is I want to prune this down somehow. Let me copy this. So this is, I want to say this is like an A-star search, right? Where I know how much I've done now, and I can estimate what the best is. So let me look up how to do an A-star search, because I don't know how to do it. I'm sure I did once, but okay. So here's what I want to do is All right, here's my idea. Best possible int. Okay, and so now def best possible let's do this. Def best possible self uh, let's say so far, which is an int, remaining steps, which is an int, and open, which is a set of string, goes to int, and let's say closed flows equals that, and let's say sorted first equals true. Okay, and actually, let me do it this way. I don't want reverse equals true, but what I do is I want minus remaining steps. Okay, so if I have 10 steps left, I want to sort this and then take the last 10, and then I want to return sum of I plus 1 times flow for I flow in enumerate closed flows. This is going to be a slight overestimate, but that's okay. As long as we're overestimating best possible, that's fine, okay? And what I want to do is I'm actually going to do negative best possible, which is a huge nuisance. But I need to do that because a priority queue is going to, it wants the smallest, right? So, so we'll see if this works. I may be like way off, right? So Q equals Q item. So let's say best possible equals self.possible. Okay, Q dot item negative best possible. Okay, okay, and now NBP equals heap Q dot heap pop Q. Okay, and if and so if NBP is if negative NBP, so the best possible is less than best, then return best. Okay, so the best remaining possibility is less than something we've already achieved. Otherwise, if time equals num steps, best equals max best released, continue, valve if valve flow, and loc is not an open. Let's just say NBP equals self dot best possible of released, num steps minus time 1, open or loc. Yep. So BP minus BP, and then heap Q dot heap push item. Q item. Otherwise, item equals we're going to get a worse best possible now. BP equals self best possible released and item equals Q minus BP, and then heap Q dot heap push Q item. All right, so let's try this and see if it works. I don't know if it'll work, but it seems more like it worked than the previous one. Still too slow. All right, let's add some prints and see. Okay. Let's say item equals heap Q dot heap pop Q print item, and then print len Q. Okay, so let's run this and see how much junk it starts generating. So 16 released equals 0, open equals set. So that shouldn't be true. So I feel like there's something wrong here. Print so far remaining steps open, print closed flows, BP equals this, print BP, print. So let's see. And I need to return it. Return BP. So let's see what this is doing. So nobody is ever opening anything. So why is that? me do that, and then, because somehow I'm not enqueuing things correctly. So now let me do one more thing, which is print pushing item, print pushing item, print popping item. Okay. Okay, I tried to stop that pretty fast. I don't, okay. Say num steps equals 0. I hate doing this, but num steps plus equals 1 if num steps is bigger than 100 break. Okay, so this will just allow me to look at the first 100 or so. Okay, so I'm at AA times 0 released 1. So I pop that. So I could be at DD time 1, could be this, could be this. And so now I'm popping and let me print ahead of this one too, because easier to read that way. Okay, so I pop this and I push these 3. So now these all have the negative backs. Pushing this time 2 released 0. Okay, and now when I pop this, I should be popping. Okay, let's say A equals Q item minus 534 BB 100 0. And why should how is time 100? That shouldn't be possible either. So that's another problem. B equals negative 600. Um, um, okay, so there's a number of problems here. One is that we're not adding to released. So why are we not adding to released? We are not. Okay, so that's fine. Popping that, pushing B. See if I open that, then print. Okay. Um, okay. Steps remaining equals num steps minus time. With print steps remaining. Okay. -1. BP loc time released plus. And let me just do this. I don't need to go 100 steps. I can go like 10 steps probably and run it again. Opening valve with flow 13, steps remaining 1. Why are steps remaining 1? Okay, well that's part of the problem. Start 0, sets, time, steps remaining equals, fuck, why do I always do this? Because I overwrote, okay, valve BB, pushing Q item minus 534, released equals 364. Because okay, so let's say flow equals valve.flow times steps remaining -1 BP, and this should be released plus flow, and then released plus flow. Okay, let's try this one more time. Negative possible 898 times CC, and then I could go here and here, and then I could go here and here, and I could go here and here. Okay, so now let me not do that, and let me just run it. And let me take out these print statements too. Do one more thing. Print new best, print Q item. Okay. So now let's try this one more time. And is it ever even going to get to that? It is not. Okay. If count mod 100,000 equals 0, print count print Q item. that ran, and that released 1594. And what was the best they told me I can do? 1651. Um, what is the most pressure you can release? Um, and let's do one more thing, and let's say valves with flow equals K. Steps or valves with flow equals open. So out of time or all good valves are open. Okay, so let's try that now. New best 1594. So here we, um, but we know that's not actually the best because the best was like 1601 or something. Um, so let's see what I got wrong. Uh, 1651. If files are open, move to DD. You open DD. DD opens 20. I think I probably went off by one error, right? So let's think about this. Um, let's. Okay, so we'll start at time 1. Um, steps remaining equals num steps minus time. So, but that should make things worse even if I do it that way, right? That's 1513 versus 1594, so that didn't help. Um, oh, so let's see. Am I starting at the right place? $16.51. How can I get new best twice? There we go. All right. New best 1513, released 1513, and it wants me to get 1651. So let's say 1651 minus 1513 equals a difference of 138. So, and what's the total flow? Sum s dot flow for s in sensors. Sensors was yesterday. What the heck did I call this? Network. 81. So it's not just a off by one error. It is something more subtle than that. So let me think through this one more time. Remaining steps, print closed flows, best possible so far plus sum I plus 1 times flow for I flow, and enumerate closed flows. Okay, so got the so far baked into that. If valve.flow, flow equals valve.flow times steps remaining minus 1. Okay, so let me, if count is bigger than 10, break. So let's try this again and see what it says. Okay, so opening valve with step 2, and so that releases 13. I don't care about this. And I want to start at 0 again, so let me do this one more time. Okay, so I'm popping at time 0, I'm at location AA, nothing released and nothing's open. So I can go to D, I, or B. Again, release 0. And now notice the negative best possible should change, right? So let me fix that as well. So like at time 2, when I haven't released anything, negative best possible should be, let's test that out. Network dot best possible 0, 30, 688. And then if I have 29, 688. And then if I have 28, 688. And then if I have 2, that shouldn't be right. So there's something wrong with this function. So let's say closed flows equals, okay, so this is from smallest to largest. Total equals 0. While, and let's say, while remaining steps is bigger than 0, and closed flows. Yeah, that's what I wanted to do. And then return tote. Okay, so let's try that. Network best possible. Okay, so if there's 30 remaining steps, it says 2308. If there's 20 remaining steps, it's 1498. And if there's 10 remaining steps, it's 688. So now let us run this. I don't know whether that would make a huge difference though. But anyway, again, let me comment out all these prints. I wish I had a better way to do this, but I tried doing it a different way that didn't work. Seriously? That went fast. Okay, so that didn't work. Oh, duh. I added this in here. That was stupid. Okay, let's try that again. Let's try that again. 1651. Is that the right answer? That sounds familiar. All right. Well, Let us see. I already have this. Let us see if that works. With open day16.text as f. I worry this will just take too long, but it might work. Is it also 30 in AA? Let's check that. All right, let's try it. Did I take out the print every 100,000? No, I didn't. I'm in no hurry. Let's let this run and see what it does. I feel like I probably need to be smarter about pruning this, but whatever. I'm in no hurry. I can let this run. I'm not trying to win. Although we could be here a long time. Maybe I'll just let it run overnight or something and see if I get an answer. All right, well, while this is running, let us think about how we got to optimize this further, because clearly it needs further optimization. So one optimization could be to avoid backtracking, right? So let's, I mentioned that before, but let's try it again. So let me do current path, which is going to be a tuple. No, it can be a list of strings. That's fine. Okay, and so here's what I want to do. Current path equals nothing. Okay, and current path equals Q item, this whatever. This is fine, this is fine, this is fine. And if I ever open a valve, then reset current path when I open a valve. If tunnel in current path continue, backtracking is a waste of time. Otherwise, current path plus tunnel, right? So now let us try this. And hopefully this will cause us to waste a lot less time. I mean, already we're getting to like time 14, time 15, and so on. time 18, time 15. So that was an optimization I thought of before. That basically, you know, if I go from A to B, I don't want to go back to A again because I've just wasted time. But if I go from A to B and then I open the valve at B, then I reset my current path because then I might want to go back to A again. Um, but this is still taking forever. So there's probably um, a better optimization as well, which is um, what is this other optimization? Let me think about it. Like I want to be tie breaking, right? So when I choose the one with the best possible, um, even then I want to pick the one that has the most. I could pick the one that has the most released. I could pick the one that has the most open. I could pick the one that's earliest in time. I'm not sure if any of those is necessarily a good idea. Um, I know this is going to run for quite a while, I think. Uh, thing is, as the time goes on, the things you can necessarily add to yourself get worse. So I'm just going to watch this for a bit and think about, well, while it's running, I'll think more about what other kinds of optimizations I can do. It's also possible that part of why it slows that I have too many things in the queue, um, and just storing a lot of them. Uh, so okay, we're gonna time equals 20, which is good, but it'll be going for a long time still. Um, I mean, another optimization is that um, if I have two states that are equivalent, but one is earlier, um, that seems like hard to do. Anyway, I'm not going to continue. Well, I'm just going to let this run overnight and see if it stops. If it doesn't, then it was clearly the wrong solution. But if it does, then maybe that's okay. But I don't feel like thinking about this anymore right now. So.